you guys want to talk about 24 and 26 real quick? We can do that. I know you guys may still be working on 33 and 34 some, and that's fine. But 24 and 26 you guys mentioned because they are unique, right? So, in case anyone's totally lost, I'll start at the beginning though. Officially 24 and 26 say solve the inequality graphically, which means I don't have to do anything algebra, I just have to graph it. What do I have to do before I can graph 24?
Bring the 6x to the left side.
Yeah, bring that 6x over and then put it in appropriate order, right? Which I guess if we're just graphing it, we don't have to, but I always say x squared minus 6x plus 9. Whoops. Until we subtracted the 6x over to the other side. So now when we graph it, we're going to graph y equals x squared minus 6x plus 9. I'm going to put that on my calculator. I'm going to do a zoom 6 because I don't know what I last graphed. Okay. And the question really becomes, what's happening at the x-axis there, doesn't it? Okay. Couple of techniques. First of all, trace. You can use trace a little bit to kind of like if I hit trace and then I arrow over, and if you watch there, does my y value ever go negative? It gets very small, like that 9.1827e negative 4, that's scientific notation, so 0.000 and then the number, okay? But it never goes negative, does it? So that makes us think that it probably stays right there. Now, in all honesty, I'm not sure I feel like I can see this very well. And so an option we can do is we can zoom in. Now, one option is to just go ahead and hit zoom in and do that. I've introduced ZBox to a few individuals. ZBox is a really good one to use when you just want to see a specific portion of a graph. So if you want to practice ZBox with me, it's number 1. And what it does, when I go into ZBox, it gives me a cursor. And what I'm doing is I'm picking, okay, I'm going to draw my box where I want to zoom in. So if I put my cursor right there and I hit enter, that puts kind of like a corner of the box. And then if I move over and down or down and over, however, and to my other diagonal, so I'm putting diagonal corners of my box, when I hit enter, it's going to zoom in specifically what's on my box or what's in my box. And so now, when I hit enter and zoom in, that gives us a better visual, doesn't it? And if you hit trace, notice, what did it take me straight to? Oh, it didn't take me quite there, did it? That was going to take me to 3, 0. But can you tell where it's crossing the x-axis there? Or touching the x-axis. Let me use that word. Again, is it ever going below? No. So this parabola is just touching the x-axis at 3 is what it's doing. Okay, it comes down, it touches, and it goes back up. And that's happening at 3. So, what did our question ask us? It wanted less than or equal to, which means we want to know when is the graph at or below the x-axis. And I say at or below because it's equal to, right? When is it below the x-axis? Does my graph ever go below the x-axis? No. If it just said less than, we'd say no solution and move on. Because it says less than or equal to, does it ever touch the x-axis? And it does. Where does it show it's touching the x-axis at most likely? At 3. So our solution there is just x equals 3. The answer key just has as x equals 3, or my typed up answer key. Yeah, and that's what the book has it listed as too. Okay? Because it's just about, it never goes below, so it's never less than, but it is equal to 3. Or equal to 0 at 3. Does that help a little bit with that one? Okay, 26. Well, it's already equal to 0, right? So essentially we're going to graph y equals 9x squared plus 12x plus 4. So let me clear off here. 9x squared plus 12x plus 4. I'm going to do zoom 6 because I was just really zoomed in, wasn't I? Actually, let me flip this over this side so I can still write. Aha. Sorry, I'll get myself situated there. Okay. Similar situation is happening if you've already explored this problem, right? Now again, you can trace, and as you trace, you'll notice that your y values never go negative. So that's a hint, it never goes below the x-axis. If I zoom and I use number 1, z-box, in other words, I can get it so that I'm just zooming in right there on the vertex of the parabola. And hit enter again. Okay. If I trace now that I'm in here, watch those y values. Does it ever go down below? Okay. My y values never go down below, do they? So, what is this question asking? Greater than or equal to says what? Where is it at or above the x-axis? Okay, last time it was where is it below the x-axis? Where is this at or above the x-axis? Does it ever go below the x-axis? No. So it's always at or above the x-axis, isn't it? So what kind of answer does that look like then? Yeah, all real numbers. Okay. And, I mean, it is all real numbers. Thoughts on what that looks like in terms of interval notation? Yep, you got it. Negative infinity to positive infinity. Infinities, of course, always use parentheses. So yeah, a couple of special cases. Okay. I haven't put the answer key up yet, have I? Or wait, are you guys even ready for that? I'll go ahead and do it. If you're still working on 33, 34, you're still working on 33, 34. You know what? I might as well I'm recording this right now for answers so my home people. I'm just going to go ahead and put this up here. So if any of you, and I'll send an email to my quarantine people later, if any of you are watching, here's an answer key to check with so you can see if you're doing anything right. Okay, hopefully or make sure you're not doing anything wrong. I don't know how to state this. I know some people are struggling with this one, so I'll put that up there. I think I'll just leave the video running for a moment to make the longer video, though. That might not be better. Do a quick check around. And as always, you guys, you are self-judges, right? You know if you're doing this stuff right or not. You know to be honest with yourself. Okay? which makes sense. I can handle that.
Okay.
I am. You got done. You're like, I'm done with it. It's good.
Yeah, I've been doing that.
And that's fine. As I said, yeah, if you got the. Okay. I'm guessing you don't want me to check yours yet. Still working. Nope, you're fine. You're fine. Okay. So I had to figure out how to count there for a moment. Okay. Looking good. Okay. Yes, Jacob?
So 18 through 26, you just have to do on the like the graphic
Yes.
calculator. All right.
Yeah, so 18 through 26, whoops, sorry guys. You did not have to do any algebra with. Like, you didn't have to graph them out or anything like that. It was a matter of graphing on the calculator. You can use the calculator to find your zeros or x-intercepts and then go from there.
All right, that makes a lot of sense. I could not figure out 22. I was trying to solve it graphically. Not
Yeah.
graphically,
Algebraically?
yeah.
And the algebra doesn't work there, does it?
It did not.
So, should we look at, is there one we should look at real quick, like 22?
I think I get it. I was trying to do all of them.
Algebraically? And honestly, you're probably opposite of some, because I probably had some that tried to do more graphically than they did algebraically, so. Okay, your homework tonight, you still have a couple minutes of class, is to work on the Chapter P review worksheet. Yeah. There's 32 questions on the Chapter P review worksheet. So it's not, it could be a lot worse, trust me. Sometimes my review worksheets and pre-cal get big just because there's so much material. So work on the chapter review, that worksheet. And then tomorrow we will go over some questions. I tentatively have the test scheduled on Wednesday. We'll see what happens, okay?